Next notes, we're going to work on something called U sub.
You suck.
Yes, exactly. I love how I just turned on the video and that's the first thing that Evie will hear is you suck.
Oh.
You suck.
Wow, okay,
Sorry,
that's me. There you go. Okay, so U sub. The idea here is, as we saw, the sine of 3x squared turns into the cosine of 3x squared times 6x. So how can we undo that? Well, what we're going to do is we're going to try and replace all of the x's with u. We're going to reverse this process. Okay? So, the first thing we're going to do is we're going to look at, well, what is going to be easiest to cancel? Okay? Let's look here. I have on the inside an x cubed. On the outside an x squared. Thinking about it with the chain rule, where did the x squared come from? Imagine that you were trying to figure out what the antiderivative is, right? Where would the x squared come from with the chain rule? How do we get x squared?
X cubed over 3.
Yes, exactly. So, honestly, the answer to this, we already have it. It's e to the x cubed divided by 3, and we're done, right? Just off the top of your head, you're done. That's all you need to do.
Wow.
No. What you need to do is look at, okay, well, what can I take the derivative of in order to cancel something else? So here, as Luke pointed out, I'm going to go ahead and say, okay, well, here, what's the inside? You will want to look at the inside and call that your u. So I'm going to say my u is equal to x cubed. And therefore, I have now a new integral of the integral from of x squared e to the u dx. Now, in order to use u sub, in order to take an integral in this case, we don't know how to do multivariable integration. And you're not going to know that until, I think, top 3. So for a lot of you, for most of you, for all of you, it's college. So I can't really do anything here. But what do I want to get rid of then? I need to get rid of dx and x squared. So how do I get rid of dx? Well, I can take the derivative over here. So the derivative of u equals x cubed is going to be du equals 3x squared dx. And now what do I need to solve for? I need to solve for dx, because that's what I'm going to try to replace. What do I want to replace dx with? Du. Because in order to integrate u, I need to have a differential of u. So I'm going to solve for that by dividing by 3x squared. I get that du over 3x squared equals dx. And notice what's in our denominator here and what's in our numerator. We have an x squared. So what are those two going to do when I input it? Well, let's see. We get the integral of x squared e to the u times du all over 3x squared. The x squareds are going to cancel, and we're left with the integral of e to the u du. And I'm actually just going to go ahead and toss the 1/3 onto the over 3 onto the outside. 1/3 here. And then integrate it. What is the integral of e to the u du? E to the u. Remember, e to the u, the derivative and the integral of that is going to be e to the u. So I'm going to get equals 1/3 times e to the u. And now what do I need to input back inside? Because I don't want to end it in terms of u, I want to end in terms of x, as we started here. So Catherine, where do I get my u from?
X squared. X cubed.
X cubed. So therefore, my u is going to equal x cubed. So my answer is e to the power of x cubed. All right, and we're finished. Over 3. Oh, almost forgot the over 3. Right?
I hope so.
Yes, maybe.
Catherine?
If you say so.
Yeah, there we go.
Oh, yeah.
Plus C. You all failed. My gosh, you forgot everything over 4 days.
No.
And how do you know if this is correct or not? How do you know you didn't make a mistake? Well, what can you do really fast? Take the derivative to check. Okay? So as you can see, it's really it's very similar to how we do the chain rule. Identify the inner function. You have to look at this and say, what would I call my inner function? Definitely the x cubed. So that's what I'm going to replace. But you also have to look and see, what do I want to get rid of? What can I use to cancel? And you look at which one. If I take the derivative of x squared, will that get rid of x cubed in this exponent somehow? No. But if I take the derivative of x cubed, will that get rid of x squared? Yes, because 3x squared cancels with x squared. So, for this one, it's going to take you a while to learn. We're going to take all today and all tomorrow. We're quizzing on Thursday, by the way. But we're going to take all today and all tomorrow to just practice this over and over and over again. All right? Now, let's go ahead and try this one. I want you all to look at this and see which one, what are you going to replace with u here? I want you to try and decide for yourselves. Not necessarily a guessing game. You always want to kind of look at what's inside. So what looks like it's inside?
X squared.
Oh, that's
It's literally on the inside.
I would say which one? X squared or 1 plus x squared? Which one do you think is going to be better? You can do both. I would actually have to check if you can do both. I don't, off the top of my head. Let me see if you write cancels. With the square root of 1 plus. It's going to be hard because you're going to have a square root of 1 plus u. You could do it. It's just going to be a little bit harder than you need it to be. So I'm going to replace the inside. U is going to equal
1 plus x squared.
and then I'm just going to write it out. What's du going to equal? 2x dx. And then solve for dx. I know that dx equals du over 2x. Then I just come over here and replace everything. The integral of 6x times...
Isn't dx plus 2?
1 plus x squared. The derivative of a constant is always equal to 0. No, that's okay. I know that's the integral. When you do this, the hardest part is that you're doing derivatives and integrals at the same time, and that can always mess you up. Okay? So, we have the square root of u here, and we have 6x times the square root of u, times du now, divided by 2x, which is going to give me 3, or you can put it on the outside, 3 root u, or u to the power of 1/2 times du.
Cancel.
6 divided by 2
Oh.
gives you 3 there. So 3 times the integral of u to the 1/2 times du. Now, what is the, can anyone give me the integral of u to the 1/2? Connor is about correct. No natural logs here, because remember, that's when you have an x in the exponent, or a u in the exponent.
square root 1
Remember, the antiderivative, yes.
Oh.
It's
Antiderivative.
3 halves x to the 3 halves, right?
You divide by the power.
That's what I did.
Nope, 3
Would
half.
it be 2/3?
It would be 2/3.
Oh, 2/3.
2/3. So here we're going to get 3 times. And remember, when you're doing antiderivatives, where you use the power rule, what are we going to do with the 1/2? We're going to add 1. So what's 1/2 plus 1?
3 halves.
And then divide by 3/2, which means you multiply by 2/3 times 2 over 3. The 2/3 are going to cancel. We have plus c here. These two cancel out. We are going to get 2u to the 3/2 plus c, or 2 times 1 plus x squared to the 3/2 plus c.
Where did you get 2/3?
Because remember, whenever you use the power rule, you have to divide by the power, correct? Such as if I do what's the integral of x squared? You have to go to x cubed and then divide by? Yes. So here we have u to the 3/2. What happens when you divide u to the 3/2 by 3/2? When you divide by a fraction, you multiply by its reciprocal. Okay. So questions on this one? Again, for a lot. Oh, sorry, Emily. What do you mean here?
It's like 3 and then integral
Well, whenever you take an integral, the du disappears. That's how you kind of get rid of it. The idea is similar to this, Emily, if you want to see here. We have, let's say dy over dx equals cosine of x, right? I would get dy equals cosine x dx, correct? And then if you integrate both sides, well, what's the derivative of 1 dy? Just y. What's the derivative of cosine x dx? It would be sine of x. Whenever you take the integral, it undoes the derivative, which undoes the differential portion. Same thing as over here. When we did it here, the du that was here disappeared because because again, we undid the derivative with the integral, which undoes the differential. Make sense? Okay. Now, oh boy. Thankfully, we have some of this stuff up here from pre-calc, because now we need to use trigonometric identities to evaluate this integral. Oh, it's great, isn't it? So
I thought we
excited.
didn't have to use those ever again.
Oh no, these are always staying. These are always staying. Sine squared plus cosine squared equals 1. That's really the biggest one you have to remember, although others will pop out. So, I have sine cubed of x dx. Well, what can I separate sine of cubed of x dx into?
No one knows.
Well, always look for Pythagorean identities whenever you have any trigonometric functions like this.
Sine times sine times.
Close. I have sine, and then what do I want to keep though? Sine squared. So I'm going to come here and say this is the integral of.
Wait, sine times sine squared, and then sine squared is equal to.
Yep, there you go.
Oh, 1 minus cos squared.
Perfect. Look at that. See, you all got it.
Yeah, Emma definitely didn't look at the board for that.
Yep. So sine squared times sine of x dx. Then this integral is going to turn into.
Wait, did we get the board for the quiz?
No.
Wait, it's actually not ours, so you don't have to.
Just
So,
memorize all that.
I know, but it's getting erased tomorrow, honey, for them. So, sine squared is going to turn into, if you notice, sine squared plus cosine squared equals 1. Therefore, I can turn that into cosine squared, or 1 minus cosine squared. And why would I want to turn it into 1 minus cosine squared? Well, because what's the derivative of cosine? So that will cancel out the sine. Whenever you see a sine in there, what's the only way you can cancel out sine? The derivative, which gives you sine. So therefore, you need a cosine somewhere in here. So this becomes 1 minus cosine squared sine of x dx. And I'm going to replace everything. What should I replace? Sorry. I'm going to look here and replace my cosine. Not cosine squared, but cosine. So 1 minus u squared times sine of x dx, where u equals cosine x.
Why isn't u equal to 1 minus cosine squared?
Because then we have cosine squared. And cosine squared isn't a nice one to take the derivative of, because then we have to use the product rule, and we have multiple portions. We have a plus in there. Do you think that plus is going to cancel easily with just sine?
No, but with the square root, when we took the derivative, or we said u is equal to 1 plus.
Because because if we take the derivative of 1 plus u squared, what does that mean?
2
We know how to, we can easily take the derivative of that. Here, the sine squared, cosine squared, it's not going to work as well. You have to look at what's on the outside and what you can take the derivative of. Sometimes you have to do tests multiple times. It's just as you do more and more of these, this is one of those things where practice makes perfect. You practice over and over and over again to get to the point where you can actually just do it pretty consistently. So we get du is going to be equal to negative sine x dx Therefore, dx equals du over negative sine of x.
How did you determine, like,
What to use u sub for?
yeah, like why?
You just have to practice. You look at, how do I cancel sine? What do I need to divide by? What do I need to divide sine by to cancel it? How do I cancel sine? Yeah, you need to divide by sine. So what do I have to have down here no matter what? I have to have sine. So how would I get sine? Well, what's the derivative of cosine? Sine. You have to look at what's on the outside and how you can manipulate the inside to get to there. Now, we have the integral of 1 minus u squared sine of x du divided by negative sine of x. These are going to cancel, and we're going to be left with the integral of negative on the outside, I'll just put it on the outside for now, 1 minus u squared du. Or, du. Then we integrate this. What is the integral of 1 with in respect to u? Nope. In respect to u. It's going to be u. So we're going to get negative, parentheses, u minus the derivative of, sorry, the integral of u squared. Add 1 and divide. U cubed divided by 3. And then we have plus c.
Oh, that's the I see.
Yep.
Why is the derivative of 1u?
Because no, sorry, the integral of 1,
Oh.
not the derivative. That was on me.
Why is it u?
Think about the antiderivative. How do you get 1 as a derivative? What's the derivative? X. So therefore, what's the integral of 1? X.
Yeah.
Yeah. So you just have to do you have to think about, how do I get a derivative of this, and then go backwards from that. The derivative of any constant is the constant times the derivative. So if what's the derivative? What's the integral of 4? 4x. What's the integral of 4? 4x.
Oh, and just because u is our variable right now?
Yes, exactly. U is what we're integrating with. We replace the du's. We replace x with u. All right. Then I'm going to distribute the negative. I get negative u plus u cubed over 3 plus c. You never actually have to change the sign because c is any constant value. So even if you multiply it or add it by a number, just keep it as c there. It doesn't really matter.
So it would be minus c?
Doesn't matter. Always just leave it as plus c, honestly. That's going to be the easiest. Okay, and now all we need to do is replace u with cosine. Okay. Are we feeling pretty, how are we feeling after that one? Yes, I know. That's, you gotta, seeing the trigonometric identities, don't worry. These aren't that bad, because I mean, we'll see one that's bad in a second. Yes?
Are they gonna be like this one quiz? Like that one?
I have to double check, but probably 1 or 2. No, probably just 1. But, under a minute?
No, not this one, Connor.
No.
He's thinking of memorization.
Oh, you're thinking of the memorization thing I'm doing. This is an actual quiz, not the memorization quiz I'm talking about.
Yeah, what's the memorization thing?
At some random point in this unit, I'm just going to say, hey, we're going to do a memorization quiz. Do these 5 integrals as fast as you can. I'll be like, what's the integral of 1 over x? What's the integral of 3x squared? And so on and so forth. Not hard ones, not these, just basic integrals, so you get those down in your brain.
Just memorize the chart from class last week.
Yeah, pretty much. Okay, now, let's say we have a definite integral instead of an indefinite integral. We're not going to see these too much because this is our indefinite integral unit, but we have the integral of x over x squared minus 9 from a equals 0 to b equals 2. So, I'm going to draw this out. We have the integral from 0 to 2 of x over x squared minus 9 dx. Okay. Now I want you to talk with the person next to you. What are you going to use u sub on? It's going to be the x on the top, the x squared, or the x squared minus 9. Which one?
I don't know why I guess do x squared minus 9. Let's do x squared minus 9 because then it will be 2x. But I don't know what you're saying, so yeah. Pay attention.
Yeah, that's
Oh,
Bruh.
Well, you could do it. All right, can someone tell me what? Raise your hand if you chose x squared. Raise your hand if you chose x squared minus 9.
Yeah.
I will say right now, x squared minus 9 is going to be easier
Yeah.
than just x squared.
Just
Okay?
because-
So let's go ahead and do this. We have u is equal to x squared minus 9. Therefore, du is equal to 2x dx, and dx equals du over 2x. You should always write this process out. This is not like the chain rule. U sub is something that I would not encourage you to try to skip past until you've probably done at least 100 or 200 of these integrals. It gets there's a lot of errors that can happen very easily in U sub that makes it impossible to integrate. Now, we have the integral of x over u times du over 2x. These cancel, and we're left with the integral of 1 over 2u, or I'll say 1/2 on the outside times 1 over u du. I always like to get those constants outside, especially at the beginning when you're integrating, so you can easily see, oh wait, that's an easy integral that I remember from our little chart. Or that's, oh, I remember what gives me that derivative. Can anyone tell me what the integral of 1 over u is? Natural log of u. So I get 1/2. Oops, don't forget the 0, 2. 0, 2.
We're gonna need to memorize stuff like that.
Yes. 1/2 times the natural log of u. However, what were my x coordinates here from 0 to 2? But do we have x? Do we need x coordinates anymore?
No.
Not really. What do we need now? Not x coordinates, but
you.
so if we know that u equals x squared minus 9,
Oh.
what would I need to do with 0 and 2?
Plug them Jones in.
Plug them in. So really, even though I wrote 2 and 0 here, that is not correct. Instead, I would say u at 0 equals -9 is going to be my new lower bounds, and u at 2 is going to equal and the nice thing about this is I don't have to u sub back in. I can just keep my u. So we have here 1/2 ln of u. And do I need a plus c at this point? No, because it's an indefinite or definite integral. It's a definite. Therefore, what's going to happen with the c's? They just cancel each other out. So I have 1/2 ln u from -9 to -5. Now, one thing to remember is that whenever we do integrals or derivatives, whenever we get the natural log of u, can we actually get negatives inside of natural log?
No.
No. Whenever you take the integral of 1 over u, since we're undoing something we already did, we have to assume that it is always going to be positive. So we're always going to, whenever we do this integral, absolute value of u. Or else a lot of the integrals that we do will just cancel out very easily. So we get 1/2 times the natural log of the absolute value of -5, which is 5, parentheses, minus the natural log of the absolute value of -9, which is 9. and now we're finished, right? No. Because this is where we toss back in some properties of logarithms on the multiple choice. You will always have different forms of answers. They will tell you, we will give your answer in one logarithmic expression, or on the multiple choice, they'll have it in a form like, that's not in my, I think I did everything right, but that's not the answer. There's no answer there. So what do you have to do? Well, what does minus mean for natural logs? Divide.
Oh, God.
So this is equal to 1/2 ln of 5 over 9. And wait a second. What does the 1/2 on the outside of a logarithm mean?
No one knows.
You can like move it up or something.
Yes,
I don't
Caleb is
know.
correct.
Actually,
It's a-
1/2
You like do the thing.
Multiplying on the outside is a power for that.
well, yeah.
So,
Bro.
100%.
Bro.
Come on, my
I remember-
Algebra 2 kids can do this.
I remember when we memorized
Well,
this
I'm
and
not
then
an
I
algebra
forgot
two.
it like a week later.
Yep, so this become there. But wait a second, we can go further than this.
Oh my God.
Because what does the power of 1/2 become?
No one
Square
knows.
root. The natural log of the square root of 5 over 9. But wait, can we do the square root of 9?
Oh my God.
Yes, we can.
Yes, we can!
Oh my god.
The natural log of 5, the square root of 5 divided by 3 should be your final answer.
Oh wait.
But we can go now.
That's exactly what
But now we're going to undo
Well, what is the
everything.
log natural of the?
Is there
the
no
cube-
plus C in
the
this?
square
No,
root?
because remember, if we're doing a definite integral, we always, do you see this minus here?
Yeah.
If we had plus C here and plus C here, what happens? Plus C minus C, they're going to cancel. That's why for definite integrals, all last unit, we never use plus C or
How do you know when it's not a definite?
when you don't have this, or you don't have numbers there.
Okay.
Whenever you see a range.
You feel like
No.
Do we
Now,
calculate this in schools?
Yes.
It says-
you do. Now, before I answer your question, Catherine. Okay, so one other thing you can do. As Grant saw, we had the 0 to 2 here, and we replaced with -9 to -5. Now, do I have to do that? Not necessarily, because what could you do? You could use the balance from 0 to 2, and what can you do with u? You could replace it with x. So instead, you could do this. 1/2 natural log of the absolute value of x squared minus 9 from 0 to 2. And if you did that, you would get 1/2 parentheses natural log of 4 minus 9 minus the natural log of 0 minus 9. And notice, what do you get from that?
Probably the natural log of root 5 over 3. Just a guess.
I'm not going to do the whole thing, but looking here, notice we get the exact same thing. So either you can input x back and use the same bounds of 0 to 2, or you can keep u and find new bounds. It doesn't really matter what you do. It's kind of up to you, but I will say that choose one and stick with it. Okay? Either choose to keep u on your definite integrals and solve through there, or change to x always and keep the old range.
What did we do for the problems above?
There was no definite integral, so we didn't care. That's why we have the plus c.
No. You just do it here or you can do
Okay.
it here. It's the same.
So, this is going to be a good time for you to practice and ask questions. We're going to do number 1 tomorrow in class, because number 1 is a doozy. It's a fun one, for sure. Your homework for tonight is going to be 1 and 2, 5 through 16 odd. Or just, actually no, sorry, wait, let me see number 2. Hold up. So it's going to be 2, 2 and then 5 through 16 odd. We'll do 1 tomorrow together.
16.
Wait, hold up. That'll be it, but I'm actually going to walk you through. I'm going to give you all about 5 minutes to work on some of these, and then I'm going to show you how to do number 1. Because number 1 is a fun problem. All right, everybody say bye to Evie.
Bye, Eddie.
Bye, Evie, and Isaac, if you're watching. You can't watch these anymore, just saying.